Hello everyone. I hope you people are following my previous lectures to understand the different example programs that can be generated by using your SIC or SICXE. In the today's lecture, I'll be focusing on string operations, how to generate the SIC or SICXE program for string operations. So first let me consider an example for the string operation to be a string movement. So here I'll consider the operation to be a string movement. So when I say the string movement, in a sense, for the case study right now, so let me consider very simple thing as if suppose if the string 1 has some content in that is called as, let me assume that Bengaluru. So if the string 1 has the content as string as Bengaluru, so which I would like to push onto the string 2. Right. So what does the string 1 has? It has Bengaluru, so which I'll be pushing onto the string 2. So suppose if I have to consider here, so how I can consider or how I can go ahead in the sense, understand my dear. So this is a string which has a content, that content is a purely collection of characters. So in our, either it can be in SIC or SICXE, we don't have any data type or data structure which can be considered to be a string together. We have to deal it in the form of a set of characters, a collection of characters. So in that means how it will be in the sense, or how it will be considered. So it will be considered as, so this will be a B followed by E followed by A, N followed by G followed by A, Bengal, Lu, Ru. So what I'm trying to convey here, my dear, so we will be considering the complete content of the string, which will be a collection of characters only. So at any point of time we cannot consider that Bengaluru altogether, so we will be considered in the form of a characters like this. So B separate, E separate, N separate, in the same every character for that matter. So I repeat, so string will be considered as a set of characters or a collection of characters. So once after we consider or we think that it is a collection of characters, so in our program as well, you need to generate the program code such a way that you have to declare this. Okay, you have to declare the string 1, either string 1 or string 2, such a way that it is a collection of characters. So in that perspective, understand my dear students, so here I'll be declaring string 1 as a collection of bytes. So it has Bengaluru. So whereas this Bengaluru, if you ask me, as I told you, this is a set of characters, so I'll prefix with the C. Okay, I'll prefix with the C because Bengaluru will be considering it as a set of characters, right? So this is what Bengaluru here, so which is string 1. At the same time, as soon as you allocate the memory space in the for the string 1, so every character will be considered separately and every character will have an index. I repeat, every character will have an index. So for that index, again for your understanding, I'll just copy paste this as well. So here it will be an index. So this every character will have its own index, start from 0, 1, 2, 3, 4, 5, 6, 7 and 8. So as there are 9 characters, so the indexes, so it will as there are 9 characters in the Bengaluru, so we'll be considering to be a 8 indexes, start from 0 to 8. Right, so we need to start from the character B, so with the index 0. So I repeat, so this is what the string 1. Okay, so if you ask me, this is what string 1, right? What is the string 1? This is the string 1, right? So wherein I have to push it onto the string 2. So here is a string 2, but can you guys understand and let me know, when I have to push string 1 to the string 2, how much space should be there in the string 2? Is it not the same space as of your string 1? And in the string 1, if you assume there are 9 characters, so you have to declare string 2 as well with the same memory space. So I'll be declaring with reserve bytes of how many characters, how many bytes? It is 9 bytes, because Bengaluru has 9 bytes. But if you ask me, can't you allocate more than that 9 in the sense? Definitely you can allocate more than 9 as well. There is no restriction that you have to allocate 9 itself, but you should not allocate less than 9. If you allocate less than 9, whatever the content you will be pushing from the string 1 to the string 2 may not be accommodated. Again, if you allocate more than that 9 also, if you ask me, is there any problem? No problem, but it's a wastage of memory space. So when you want 9 bytes, if you allocate 50 or 100 bytes, so there will be a wastage of memory which you are not supposed to attempt for, right? So in that perspective, I will be allocating 9 bytes itself for the string 2 as well. So it is as same as, okay, it is as same as, so here I have allocated 9 bytes of empty spaces, right? Like this, I have allocated 9 bytes of empty spaces. Now, as I told you, my dear students, as I told you, so here I have to start, the string will be considered as a set of characters, and I have to start pushing one character at a time from the string 1 to the string 2. I repeat, I have to start pushing one character at a time from the string 1 to the string 2. If I have to point or consider each character at a time, or one character at a time, so there is a necessity of index register as well. So I will be using the index register. So my dear students, here I will be using the index register. Here I will be using the X register as an index register, where it will be made to point to the beginning, or the initially which will be made to point to the 0, the location 0. So if I have to make this X to be pointed to the 0 means, so I have to initialize the X register. I repeat, I have to initialize the X register to the 0. So here like this, I have to make X to point to the 0 at the beginning. So I have to initialize X with the 0. So I'll say that LDX 0. But does this 0 has a value? No. This 0 has no value until unless you initialize. So only what I'm going to do in the sense, I'll initialize 0 word with the value 0. So I hope you are getting 0 is initialized with the 0. That 0 is assigned with the X. So X is loaded with a 0. So it will be pointing to the 0th location of your string. Now what we are going to do, my dear students, I'll be pushing. So however we'll be considering the accumulator register right here. Okay, like this. So this is the accumulator register. I'll say that SICXE accumulator register. So what I have to do in the sense, first I should bring this B onto this accumulator register, right? Then whatever the character I brought from the, so how can I bring this B onto the B from string 1 to the accumulator register? That is where I will be doing LDCH. It's not LDA, it is LDCH, because I will be loading the character. I am not loading the number. I will not be loading any integer, I will be loading the character. So it is LDCH. From where? From the string 1. Am I loading everything? No, whichever it is pointed by X. Initially X is pointed to what? It is pointed to the 0th index, it is pointed to the B. Mind it, it is pointed to the B. So B is loaded to the accumulator register. So by using this LDCH string 1 comma X, B is loaded to the accumulator register. That itself I have to push it onto the string 2. I repeat, that itself I have to push it onto the string 2. So for which I'll be writing as STCH string 2 comma X, because X is still 0. So I have to place the B in the 0th index itself in the string 2 as well. I should not place B in somewhere else. I mean, are you getting my idea? So I have to place at the same place, the same index position of your string 2 as well. So 0th index from the string 1, I should place it to the string 2 as well, like this. I should not place anywhere else. So that is where string 2 comma X. So right, so a B is pushed, fine. Now I have to go to the next character, which is E, right? So I have to increment this X to point to the E. I repeat, I have to increment this X to point to the E, and also I have to keep incrementing until for every character until I reach to the end, right? So how can you come to know that when you have to end it? That is where will be, so for that is a process where I will be saying that TIX max. What is this max then? Max is again a variable I have to initialize as I'll initialize max with the 9. If you ask me what is this max with the 9, because there are 9 characters, so I have to keep repeating this process for 9 times. I have to repeat this for 9 times, so I'll be initializing max with the 9. So what is going to happen in this TIX? I hope in the instruction set I have a deal about this. TIX is nothing as test on increment. So you have to increment the x and test with this max. So initially the x value is 0. When you incremented the x, it will become 1. That is compared with the max. When you compared with this max, what is max? 9. So does the x is less than max? Definitely yes. So that is where we say that JLT some loop. What is that loop? So here I'll say that a label as loop. So to where I have to jump and go for the next characters, because once you incremented the x here, now the current value of x is 1, where it is pointing to the character E, and do the same process. Push that E to the accumulator, then to the string 2, right? Then increment the x, then push the n to the accumulator, then to the string 2. That same process will be continued, right? For this I'll just go with a name. Okay, I'll just go with the name of the program as I'll say that program itself. And so as usual I'll be having start instruction with the respective address, right? This is the program in SIC for moving the string from moving the content of one string to the other, right? The same program how to generate in a SICXE, or how to generate a program for the same purpose. Okay, so here how to generate this in the sense, as usual I don't for this as usual, however I have the start here, I should also have the end instruction as well, right? So here, my dear students, the little changes what I am going to make it here in the sense. So as usual, string 1 should be declared with the Bangalore, and string 2 should be declared with the initialized with the 9 spaces to hold that Bangalore. Now, so however here LDX I don't have to initialize with the 0, because by making use of your immediate addressing mode, you can directly make it as #0. Is it not? You can directly make it as #0. Then later, yeah. Then later, so as you know here we made use of one extra variable as a max. So that maximum number of times I should repeat that also. Let me place into the register T. So I'll just say that LDT #9. And here, so instead of I say that TIX, I'll say that TIXR and compare with the T. Because T is the register to which you will be comparing. When you are comparing with the normal memory space, it is just a TIX. So whereas here comparing with the T, which is the register, so I have to go with TIXR instead of only TIX. Then next, rest everything is common, right? So what we did, we initialized the x to the 0 to point to the beginning. Again we initialized the t to the 9 to get to know how many times it has to be repeated. Then we also what we did in a sense, we pushed the character from the string 1 to the accumulator register, then and to the string 2 wherever it is pointed by x. And again every time you will be keep incrementing the x and also comparing with the register t. And if it is less, then definitely you will be jumping to the loop and performing the same process until you reach to the last character, which is u. Right? Once you reach to when this condition is failed, which is if x is not less than t, you will not be jumping to the loop and you will not be continuing, you will be stopping the process. Right? That's the program for the given example. Thank you.